This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today, let's evaluate expressions with positive exponents using properties. Before we take off, let's review some basic exponent rules. 5 to the third power means we will multiply 3 5s together, and 5 times 5 times 5 is 125. When we multiply powers with the same base, we add their exponents. 5 to the second power times 5 to the fourth power is equal to 5 to the sixth power, which is 15,625. And finally, when we divide powers with the same base, we subtract the exponents. 5 to the fifth power over 5 to the third power is equal to 5 to the second power, which is 25. Okay, let's try some problems. Evaluate 3 to the fourth power times 3 to the third power. Since we're multiplying, let's add the exponents 4 and 3 to get 7. 3 to the seventh power is 2,187. Nice! Let's take a look at why this is true. 3 to the fourth power means we are multiplying 4 3's together. And 3 to the third power means we are multiplying 3 3's together. So 3 to the fourth power times 3 to the third power will be 4 3's multiplied by 3 3's, which is the same as multiplying 7 3's, or 3 to the seventh power. Let's try more. Evaluate 8 to the seventh power over 8 to the fourth power. Since we're dividing powers with the same base, we'll subtract the exponents. 7 minus 4 is 3, and 8 to the third power is 512. But why does this work? Well, if we expand our quotient, we get 7 factors of 8 in the numerator and 4 factors of 8 in the denominator. So we can cancel out 4 factors of 8 from both, leaving us with 3 factors of 8 in the numerator, which is the same as 8 to the third power. Let's try more. Evaluate 3 to the third power times 5 times 7. Order of operations dictate we should perform powers first. 3 to the third power is 27, and 27 times 5 times 7 is 945. Great work! Let's try more. Evaluate 12 to the fourth power times 12 all over 12 to the fourth power. Let's start with the numerator. 12 by itself is the same as 12 to the first power, because anything to the power of 1 is itself. So in the numerator, we're multiplying powers of the same base, which gives us 12 to the 4 plus 1, or 12 to the fifth, and our denominator is still 12 to the fourth. Now we have division, so let's subtract 5 minus 4, giving us 12 to the first, or simply 12. Now, we could have done this problem a different way. Notice how we have 12 to the fourth in the numerator and the denominator. Both 12 to the fourths cancel, leaving the lone 12, well, alone. What's interesting about power properties is often there is freedom to find different ways to approach the same problem. Let's try a few more. Evaluate 4 all over 3 to the second times 3 to the second power. It looks like the only terms we can simplify are the 3's on the bottom. Let's add their exponents, giving us 3 to the fourth, which is 81. So our final answer is 4 over 81. Let's try one final problem. Evaluate 5 to the sixth power times 5 to the third power all over 9 squared times 5 to the fifth power. Let's add the exponents 6 and 3 on top, since the two powers in the numerator have the same base, giving us 5 to the ninth power on top. Next, let's take 9 minus 5, since we're dividing two powers with the same base, giving us 5 to the fourth over 9 squared. Now we'll simplify to get 625 over 81. Great work! Thank you for working through these problems with me. Now that you know how power properties work, go practice some more. Good luck!
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.